Here are some more examples of factoring. This first example is x squared minus 10x plus 25. We could use the method where we notice that the leading coefficient is 1. So we make a factor chart of the factors of 25, which is c, that add to b, which is negative 10. Negative 5 times negative 5 is positive 25. When we add them together, we get negative 10. So the numbers we're going to work with are negative 5 and negative 5. So we split up our x squared term into x, and then we have minus 5, minus 5. Notice that these are the same parentheses, so you could also change it to x minus 5 all squared. Next example, 16x squared plus 8x plus 1. Notice the leading coefficient is 16. We could use the AC method, or we can rewrite it as a perfect square, which is 4x times 4x is 16x squared, and then 1 times 1 is 1. There's a rule for a perfect square that you can split up the 4x and the 4x, and then the 1 and the 1. If you FOIL this back out, your middle term will be 8x. We call this a perfect square trinomial. If you want to combine them into one parentheses, just make sure you put a squared. Next example is x to the fourth plus 14x plus 45. This is very similar to a trinomial where the leading coefficient is 1. We want to find out what are the factors of c, so factors of 45, that add to b of 14. So we say what two numbers multiply to 45, which is 9 and 5. When we add them together, 9 plus 5 is 14. The numbers we're going to work with are 9 and 5. So notice that we have an x to the fourth power. So we want to split this up into x squared and x squared. And then the next two pieces are your positive 9 and your positive 5. Positive 9, positive 5. If you FOIL that back out, you will get that original polynomial. Next example, 6x squared minus 54. The number one rule of factoring is check to see if there's a GCF. In this case, there is. I can take out a GCF out of both of those terms. What is the greatest common factor with 6x squared and negative 54? So you're thinking, what can divide into both of those terms? Can you take out a 6? Yes. So our greatest common factor is 6. Now what are we left with? So we're going to divide this by 6 and this by 6. So now we're left with x squared, and then negative 54 divided by 6 is negative 9. Now I can continue factoring that blue parentheses of x squared minus 9. That's a difference of two squareds. So it's x minus 3 and x plus 3. Our last example is another GCF problem with number one rule of factoring. The number one rule of factoring is to take out the GCF first. So I'm going to take out the GCF of x. That means I'm dividing this term by x, this term by x, and that term by x. So I'm left with 2x squared minus 7x minus 15. Now I need to continue focusing on only the parentheses. We're going to use the AC method to finish factoring this piece. So the AC method says take your A and your C and multiply them together. So 2 times negative 15 is negative 30. Now we make our chart. What are the factors of negative 30 that add to negative 7? Well, negative 10 times positive 3, when we add them together, we get negative 7. So we're going to replace negative 10 and positive 3 with this middle term, negative 7x. So let's rewrite the problem. X was that GCF. Then we had 2x squared. And I'm going to replace the next two terms, or the next term, negative 7x, with two terms, negative 10x and 3x. And then I still have that minus 15 at the end. This AC method has now changed to a grouping. So we're going to group the first two. And the last two terms. GCF them both. I'm going to take a 2x out of the first parentheses. I'm left with x minus 5. I take a 3 out of the second parentheses. Left with 3x or x minus 5. If both parentheses match up, that's my new GCF. X minus 5 and x minus 5 is my new GCF in this bracket. My leftovers is 2x plus 3. And then some students forget this has to come down in front. That GCF is still part of the problem. So my final answer is x times x minus 5 times 2x plus 3.